Hi everyone! Today I would like to bring you through the journey of understanding HeartBeat at Bedok. As we all know, Singapore is a delta city, so water management has always been the biggest challenge. And that is where HeartBeat located. Latitude of 1.351 degrees on north and longitude of 103.8198 on east. It is a civic community designed by Ong and consists of 45,000 square meter and 7-story height, and the combinations of swimming pool, polyclinic, elder care center, sport hall, library, recreation area, and others. HeartBeat has also won a few awards from BCA, the American Architecture Prize, World Architecture Festivals, and Asia Pacific Property Award. From the climate data, we can see that this is a tropical climate where the general pattern is around 24 to 28 degrees Celsius of a warm weather. These are the main green features of HeartBeat: green roof, solar shading, and others. We will be explaining on the topic of site planning, building structure, HVAC, lighting, ventilations, thermal performance on roof, and most importantly, the facade. The HeartBeat building is higher than the surrounding buildings, so it helps to create the right amount of shades. And because it is a massive structure, it will need to occupy big amount of daylight to reduce the energy consumptions. From the wind rose diagram, it allows cross ventilation to pass through the atrium and pedestrian. With the CFD simulation, it helped to refine the design and achieve acceptable wind flow rates in a non-air-conditioned space. The developer took considerations into the accessibility of the park and its connectivity to the surrounding area. Large greenery is integrated into design to achieve green plot ratio of 4.5 into existing part of the park, creating a modern urban and biophilic space. Hence, the building is seamlessly connecting with the surrounding existing development. Green concrete with recycled content is used for structural beam and slabs, while innovation solutions such as hollow core slabs are used in the building to reduce related carbon footprint. Also, the contractor has also implemented extensive environmentally friendly practices during construction. As for HVAC system, the building uses large diameter ceiling fans throughout the semi-open first floor to reduce the energy consumptions while cooling down the space as in the image shown. While around 55% of the building is air-conditioned, the development is designed to reduce the energy consumptions up to 31% through the green features. HeartBeat uses an energy-efficient chilled water plant designed with an efficient air distribution system to maximize energy savings for ventilations and cooling of the air-conditioned spaces. As a result of these energy-efficient features, the energy usage index of the building is expected to be 176 kW per hour square meter per year, which is 32% lower than a typical green-marked platinum retail building of 259 kW per hour meter square per year. All the space that utilize the natural lighting is mainly semi-opened or fully open space of the building, which aids enhancing views and architecture. They also optimize the usage of LED fittings to decrease energy consumptions of the artificial lighting by 42%. The atrium on the ground floor to the second floor allows an effective cross ventilations and natural lighting throughout the space diagonally. With this, it helps to provide a comfortable air quality to the user and enhance the connectivity and visual integrations. It uses the theory of hot air rises, cold air sinks. The atrium uses the venturi effect to promote wind flow through the space, leading to a conducive and comfortable natural ventilation social space. HeartBeat consists of a water pool on the 5th story, whereby the swimming pool acts as an open roof pond to improve the thermal comfort and heat loss through convections and evaporations. With the cool pool system, the process of evaporations allows the air temperature to be reduced and causes air effect to the surroundings, and the heat that accumulates during the day will radiate away from the building at night at the open swimming pool, which results in the thermal equilibrium. High albedo roof is used on the tennis court to reduce solar radiations while maintaining the natural ventilations and lighting. It can be used to reduce building air condition use and provide a cooling effect up to 28 to 33 cooler than conventional materials. With the increase in productivity, the cleaning staff are able to redeploy to higher value work while maintaining visibility on the security of the premises. Finally, the most important element of the building: facade design. It is a biophilic facade where the foam is integrated from the formations of a sandstone rock, thus turns into a stake building foam. Through the facade, it offers daily interactions with the plants in the terraces surrounding the structures. It is also a self-shading facade which was conceptualized to reduce the heat gains. It consists of a few elements. which is the vertical fins, exterior wall, metal screens, brise-soleil, tapered windows, and vegetations. First of all, the tensile fabric vertical fins are wrapped around the right block of the building to allow ventilations and reduce solar heat radiations. It has a spacing of 1800 mm between each fin and a 180-degree torr in the middle to improve the porosity of the facade and increase airflow in the naturally ventilated corridors, as well as to reduce the solar heat gain and incidental cooling load by 30%. The vertical fin uses rigid steel frame to connect with the building, and the trays of the tensile fabric are rated as Class O, which is the most stringent classifications in terms of fire safety. It is a Teflon-coated glass that is stronger than PVC polyester and lasted up to 30 years. It is inelastic, generally self-cleaning, hydrophobic, and a high temperature resistance. Added on to that, it uses the PVDF top coat to enhance the cleanability and to additional protections. The U value of twin-layer membrane is around 2 to 2.5 watt per meter Kelvin and has a high reflections of solar performance, with a 10% and 15% absorbance and transmission solar performance respectively. Vegetation is used as a barrier and bordered around the building, as if enveloping the building within a park's forest. The greeneries also acts as a green lungs of the building to help reducing the carbon footprint amount and to provide shading to pedestrian walkways and the lower level buildings. Throughout the times, multiple layering of vegetation simulating a terrace landscape on the south facade, providing privacy and acoustic screens from the neighboring residential units. Even so, careful considerations were taken when selecting plants to complement the building usage and sociology impact. It also helps to cool down the surroundings temperature, creating a comfort conditions for indoor activities by blocking out the radiations and sustain the microclimates of the surrounding. The polyclinic has a direct access to the therapeutic garden and a view of the rolling lawn on lower levels. Furthermore, the greenery provides refreshing and healthy release spaces for respite and relaxations. Same goes to the use of the communal sky garden and terraces. End users can enjoy the views from the sport hall, the pocket garden, as well as the picnic lawn that serves a small gathering picnic space that is integrated seamlessly with the atrium hardscape. Landscape areas is irrigated using harvested rainwater and served by sensors to reduce the potable water use, resulting in an overall design that is highly water efficient. They also use 100% organic horticulture waste to fertilize the landscape, as well as a SGBC certified green label products. Next, brise-soleil systems. It is mostly placed on the west elevations of buildings to block out direct sunlight and heat during afternoon. It is also respond to parts of the glazing to reduce the greenhouse effect. This system breaking up the sun rays by using the blade of fin, which allow low-level sun to enter a building. It is a long-span aluminum brise-soleil connecting with one another using welding method, provides a good strength to weight qualities. There are also perforated metal galvanized steel panels that are placed around the building as a sound barrier to block out the noise from the roadside. It is usually using bolts to secure the mesh together with steel columns, not only to provide an aesthetic appeal, but also to improve energy efficiency and building performances on acoustic and lighting. It is commonly located in between a noise source and the sensitive receiver, creating a sound shadow zone of quiet with an adaptive noise control barriers to provide maximum noise reductions with lightweight modular panels or louvers. Tapered fenestration. A series of slanted windows which help to reduce glare from the direct sunlight while still allowing the light to penetrate in. To compare, the vertical window allows lesser passage of light than inclined window, but also allow the passage of sound and sometimes air. On the other hand, inclined window can reduce reflections and has an easier visibility of the deck, shading of the glass at lower sun angles. By using coated insulating glass, the UV value of the window is 1.2 watt square meter Kelvin. With this, it also helps to trim the construction cost by eliminating the use of double glaze units without compromising ETTV performance. Lastly, on the exterior wall, the building uses easy maintenance plaster and paint, such as the low volatile organic compound that has a low impact on the environment as well as human health. It also uses a smooth surface as the exterior to reflect light and bright color paints to absorb less heat. In the cost occupancy review, architect Lina Craig from Ong & Ong has concluded that HeartBeat now has become a local landmark that reinforces community identity and engagement in Bedok, whereby it has received more than 2.4 million visitors now. To conclude, with all the passive green strategies integrated in the building, it has not only achieved a low energy consumption but also achieved a symbiosis between man, nature, and architecture. Thank you.